Hey students, I wanted to show you how to do this. How do physical factors affect ocean life activity? And basically, this activity looks at physical factors, which in the ocean are the non-living aspects like temperature, the salt level called salinity, dissolved oxygen, the depth, tides, pH, all of those things and how they affect different animals. So if you go and just as like humans say we put in some structures in the ocean, or say we like build out a jetty or put a pier, and we think, it's no big deal, the little fishies, they can just move north a little bit or move south a little bit and they'll just have to figure it out because we want the space. Well, to some degree that's true, but to some degree, as ocean factors, like the physical factors, like if the ocean gets a little more acidic or the ocean gets a little bit warmer or we build different structures, a, a lot of times it disrupts the ocean, like food web and ecosystem, just in many cases in small degrees, but when we do that a lot it kind of adds up. But we are going to look at the different temperature ranges in this, and if fish really could move north or south, or if that is outside of their range. So, when you start this activity, you are going to first look at ocean temperatures and learn how to find out ocean temperatures using NOAA, which is the government ocean research arm of the US government. And so you're going to go to this website here, and I have the link and you can click on it. But I actually put a picture of what it looks like here. So instead of navigating out of that now, I'll just show you based on this picture. When you bring that up NOAA, it's going to usually default to the East Coast. But either way, this first question asks you about the East Coast of the United States. So you'll want to scroll over there. And when you look at it, it asks you to find the temperature of the water in each state in Fahrenheit. Okay, so I show you on this picture that when you click on a buoy, which any of these yellow things or even the red are different buoys out in the ocean that are taking down different data, and it's run by our government or maintained by the government. So here is the water temperature, and I show you where it is. Here's a certain station. I just clicked on a buoy, and all the data from that buoy pops up. You'll have to look a little bit like towards the bottom, but it says water temperature 47.8 degrees Fahrenheit. Okay. So I ask you to click on this website, and then you are going to go to these different states here: Maine, New York, Chesapeake Bay, Maryland, Virginia, South Carolina, and Florida. You're going to pick any buoy because there's lots of buoys by each state. So I don't care which one you pick. You can just pick any buoy near that state, and then you're going to write up the ocean temperature next to it. So in the answer of the question, I rewrote the states. You're going to click and write the ocean temperature from a buoy next to like Maine or New York or Chesapeake Bay and things like that. Okay, on the next set of questions, I have some different fish and other ocean creatures, and we're going to look at them. Like this one is called the grayling. And underneath the picture of the grayling, I have NOAA's ocean research data from one of their buoys saying that the average temperature for Alaska goes from all the way 39 degrees Fahrenheit when it's really, really, really cold at its coldest, but its warmest is only 49 degrees Fahrenheit in Alaska. So when they are really warm, it's up to 49 degrees in Alaska. So that's its range from its coldest to its warmest. Whereas like Vancouver, Canada, just a little south, is 43 at the coldest and 55 at the warmest. And Washington state is like 46 to 58. So you can see that we're getting a little bit warmer, and go a little further south and it's 48 to 60. So only slightly warmer than Washington. But Northern California ranges from about 50 to 62, and Southern California from about 57 to 72. Okay, back to our fish called the grayling. we're going to assume that the grayling has an optimal temperature of 45 to 58. So, in other words, the grayling can only live in 45 to 58. If it's lower than 45, it can't live there. If it's higher than 58, it can't live there. So then I ask you, which locations could it live in? Make sure to pick locations that are not too hot and not too cold. And you're going to pick one. So let's look on the 45, and any place that has like a temperature lower than 45, it would not be able to live in. So let's scroll back up. Sorry, I went off the page. So anything lower than 45, it can't live in. So we're going to eliminate Alaska because 39 is lower than 45. We're going to eliminate Vancouver because 43 is lower than 45. But Washington is not lower than 45. So Washington might be able to work. Okay. So what was that upper temperature again? To 58. Okay. So 58 at the hottest. Let's see what that Washington one was. At 58 at the hottest. Okay. So 46 to 58. That grayling could live in Washington. Let's see if it could live in Oregon. Okay, Oregon doesn't get too cold, but does the top temperature go above 58? Yes. So it does. So basically this 60 degrees is too warm, which obviously means Northern California gets too warm, and so does Southern California. So for the grayling, it says pick one. Only one place is going to work for the grayling. So scrolling here again, that is going to be Washington. So I am going to click Washington. Okay, so I'm going to do that for several other fish. Like there's the leopard shark, and it gives you their optimal temperatures, and you're only going to pick one place for the leopard shark. And then the Garibaldi. But the Garibaldi is pretty diverse. It can live in 4 different places. So you're going to look at the 4. And this is the giant sea bass. And it can live in 6 different places. Then this is a Pacific halibut. It can live in 3. And this is our spiny lobster. And it can live in 1. Okay. So go and pick from there. Then the next part of this is going to be looking at some graphing. So you're going to look at the graph changes and how much the average temperature has changed in the ocean over time from 1880 until, let me see, the first purple dot is 1950. 1950? I think it's 1880. But then over here, I want you to look at the purple dot that's over here. So basically, I want you to look at these 2 purple dots. This one here to this one right here. So this one is just above negative 0.2. And this one is just above positive 0.2. So you are going to subtract these 2 changes and find out what the change was over time between these 2 dots, okay? And then the next question is basically if California's oceans keep increasing in temperature by 0.72 every 50 years, what will be the average temperature change? So assume the starting temperature in 2000 is 72. So here's 2000, so the starting temperature should be 72. And if it's going to go up by 0.72 each year, you're going to do 72 plus 0.72. And that will be your 2050 temperature. So that's how you will do the next ones. Then you are just going to do a write-up here where you're going to describe how the rise in ocean temperature will affect the habitat of marine organisms in Southern California, what will be able to survive, and what will die off. You should have just like 1 to 2 sentences there. It doesn't need to be really high depth, but remember you are like, This is like a college assignment. And then humans on the West Coast rely on fish for food as part of our economy and part of our natural heritage. Explain how these changes in ocean temperatures will affect our marine resources. And so, in a few sentences, you should be able to answer that. And then you can submit that assignment and be done. So, that is your assignment on how physical factors affect ocean life. If you have questions, let me know.